At number 1, we are translating an augmented matrix into a system of equations. So that's just a matter of remembering what each number and the position in the matrix represent. So the 2 would be 2x minus 3y plus 3z equals 6. The second row represents y plus 4z equals negative 8. And the last row represents x plus 3y plus 5z equals 2. Number 2, we are solving a system of equations using a very specific method. We are asked to use substitution. So in substitution, I'm looking for a variable that I can very easily get by itself. And in this case, it's that top equation where it says 3x plus y equals 9. I can bring the 3x over and get y equals negative 3x plus 9. And then I'm going to substitute that into the bottom equation. So I'm going to fill that blank in with negative 3x plus 9. Then I'm going to distribute and solve. So distribute the negative 4 in, I get 12x minus 36 equals negative 6. I can see that I can already add 3x and 12x is 15x. And I'm going to bring that negative 36 over. That'll give us a 30 on the other side. Divide by 15, so I get x is 2. And then I'm going to solve for y. And that's where I'll evaluate the 2. So negative 6 plus 9 is 3. So the ordered pair that solves this system is 2, 3. In this question, we're asked to use elimination. Elimination is where I pick a variable and then multiply so that I can add and cancel out one of my letters, one of my variables. And in this case, I like the x's. I've got 3x and x there, so I'm going to multiply the bottom equation by negative 1, which gives me negative 3x plus 4y equals 6. And then I'm going to just copy that top equation over. And now I can just add. And the x's will cancel out. And I'm left with 5y equals 15. So obviously y is 3. Okay. And then I'm just going to pick one of my equations. That top one looks pretty good to me. So 3x plus 3 equals 9. And then solve for x. So I get x is 1. And then I'll write my ordered pair. In this case, 1, 3. At number 4, we are given a matrix in reduced row echelon form. So we can go ahead and solve for x, y, and z. And let's see, so that bottom row represents z equals 3, and then I can work backwards to solve for the missing information. So 3y minus 5z equals negative 6. So then I can substitute in what I found from the previous step. So 3y minus 15 equals negative 6. And 3y, let's see, bring the 15 over. So that'll put that at 9. So that means y is equal to 3. And then I'll go to the top equation. And that means x plus 2y plus 3z equals 18. And then substitute in what I already know. So I'm trying to find x. So 2 times 3 plus 3 times 3 equals 18. So I get x plus 6 plus 9. So x plus 15 equals 18. So x in fact equals 3. So just coincidental. So our ordered triple here would be 3, 3, 3. All right, number 5. Let's scroll down there. Okay, so number 5, what I'm looking for is this bottom row, and that bottom row tells me all that I need to know about this. That actually translates to 0x plus 0y plus 0z happens to equal 3. So you just think for a second. Any number I pick for x, y, and z, when I evaluate it, I'm going to get 0 on the left. And there's no way that 0 will ever equal 3. That's just a false statement. So this is an example of no solution. And so that's all you would have to write for that. And then in the last case, this one's a little trickier. Again, bottom rows of zeros says 0x plus 0y plus 0z equals 0. Well, that's actually true for any x, y, and z that you pick. So there's infinitely many solutions that exist for this one. So in this case, what I'm going to have to do is write an equation for x and y in terms of z. So I'm going to go to that middle row that says 3y minus 5z equals negative 6. And then I'm going to set up an equation and solve for y. So 3y is equal to 5z minus 6. And then I'll divide everything by 3. So I get 5/3 z minus 2. I'm just going to highlight that for right now because that's going to show up as part of my final answer. Then I'm going to go up to the top equation, and that means x plus 2y plus 3z equals 18. And I'm going to evaluate or plug in that y expression. Plus 3z equals 18. Okay, so then x plus, so 2 times 5/3 actually is 10/3 z minus 4 plus 3z. Try to make that a little bit nicer. Equals 18. All right, so let's bring everything over and then we'll worry about combining like terms. So x is going to equal negative 10/3 z minus, and I'm going to rewrite that 3z. That 3z is actually, in terms of thirds, is 9/3 z, and then that'd be positive. Oops, how many equal signs can I take? Then that'd be a plus 4 and then plus 18. All right, so that would be negative 19/3 z plus 22. And so that's going to show up in my final answer. And so my final answer is going to look like this. It's going to be the ordered triple, so x, y, and z. And these are symbols, by the way, so we do use that notation to indicate that it's going to be any ordered pair, any ordered triple, sorry, where x is defined by negative 19z over 3 plus 22, y is 5/3 z minus 2, and z is any number. So in other words, there are an infinite number of solutions, but it's not any numbers that I pick. It's I get to pick one number, and once I pick z, then z is going to define y and x. So there you go. So on the test, one of the skills that I want to see is that you can actually solve a matrix using row ops. It's a long process. It is not an easy one, and there's a lot of places where you can make silly mistakes. So just go slow and steady and just be very conscious of your work. First step is to write an augmented matrix. So 1, negative 2, 3, and 7, 2, 1, 1, and 4, negative 3, 2, and negative 2, and negative 10. All right, so my first goal is to have a 1 in that upper corner, and it is, so great. Then my next goal is to have a zeros beneath it. So I am going to multiply negative 2 times row 1 plus row 2 in for row 2. And then I'm going to multiply 3 times row 1 plus row 3 in for row 3. And that should give me zeros where I need them to be. Okay, so Row 1 did not change, so I'm going to keep it. And let's see, negative 2 times 1 is negative 2 plus 2, so I get 0, yay. Then negative 2 times negative 4, so I got positive 4 plus 1 is 5. Then we have negative 6 plus 1, so negative 5. And I have negative 14 plus 4, so negative 10. And then for 3 times row 1, I have 3 times 1 minus 3, so 0. Negative 6 plus 2 is negative 4. Let's see, 9 minus 2 is 7. 21 minus 10, that's 11. Okay, so my next goal, I'll scroll down here, is I need that 5 in the dead center to say 1. So I'm going to multiply everything in that row by 1/5. So 1/5 row 2 in for row 2. Alright, so row 1 did not change. The middle row is going to say 0, 1, negative 1, and negative 2. And 0, negative 4, 7, 11 for row 3. Alright, my next goal is to get that negative 4 to say 0. So I'm going to take 4 times row 2 plus row 3 in for row 3. That should give me a 0 there. So let's see, row 1 and 2 I did not change. Alright, so let's see, 4 times 1 plus, sorry, 4 times 0 plus 0 is 0. 4 times 1 plus negative 4 is 0. Negative 4 plus 7 is 3. And negative 8 plus 11 is 3. And we're almost done with the row ops here. So now my last goal is to get that 3 in the bottom there to say 1. So I'm just going to multiply 1/3 times row 3 in for row 3. So 1, negative 2, 3. Okay, so that doesn't change. Row 2 doesn't change. Now row 3 is going to be 0, 0, 1, 1. Okay, so what do I know? I know so far that z is 1. And then I can use back substitution to find y and then find x. So that second row means y minus z equals negative 2. So y minus 1. So y then would have to be negative 1. And then x, so the very top row says x minus 2y plus 3z equals 7. So that would be x minus 2 times negative 1 plus 3 times 1. Alright, so what is that? That would be x plus 2 plus 3, getting ahead of myself here. So x plus 5 equals 7, so then x has to be 2. So my ordered triple would be 2, negative 1, and 1.